Hello! In this video, we present the synthesis of levetiracetam, which has been labeled with carbon-11, in accordance with its retrosynthesis that was presented in our last video. This isotopologue has resulted valuable in nuclear medicine for the purpose of conducting research concerning epilepsy by using the methodology of positron emission tomography. The synthesis is carried out using parallel reaction sequences and then connecting them in the most efficient way possible, given the short half-life of carbon-11, which is about 20 minutes, and it employs the labeled hydrocyanic acid is the source of this radioisotope, as we will see later. The process for producing labeled hydrocyanic acid with carbon-11 is based upon a nuclear reaction. This reaction involves bombarding nitrogen with protons in order to create an unstable atomic nucleus that subsequently undergoes decay, transforming into carbon-11. The bombardment of nitrogen nuclei by protons, when conducted in the presence of molecular oxygen, leads to the generation of labeled carbon dioxide. This compound, which, under conditions of elevated temperatures and in the presence of both hydrogen gas and a nickel catalyst, forms labeled methane, which, in turn, at elevated temperatures, undergoes a reaction with ammonia in the presence of platinum, which serves as a catalyst for the purpose of preparing carbon-11 labeled hydrocyanic acid. Preparation of chlorobutanoyl chloride. The gamma-lactone 2, when subjected to treatment with thionyl chloride, in the presence of zinc chloride, which acts as a Lewis acid catalyst, undergoes ring opening and subsequently yields chlorobutanoyl chloride 3. Preparation of levetiracetam labeled with carbon-11. The reaction of propanol 4 with ammonia forms compound 5, which contains an imino group, to which the cyano group coming from hydrogen cyanide labeled with carbon-11 is added, to form cyanoamine 6, which then immediately reacts with chlorobutanoyl chloride to first form amide 7. The addition of sodium tert butoxide causes an intramolecular nucleophilic substitution reaction, forming pyrrolidon 8. The oxidation of the cyano group of 8, using hydrogen peroxide, converts the cyano group into a carboxamide group, thereby yielding the racemic mixture of levetiracetam. Finally, the resolution step is then performed, utilizing chiral chromatography with the goal of isolating and obtaining the pure labeled drug. With excellent enantiomeric and radiochemical purity, with the total average synthesis time starting from carbon-11 labeled carbon dioxide, being 50 minutes. In summary, here are the intermediate and raw materials and their structural contribution. Thank you for your attention.